Hello everyone, this is BSc TY class of complex analysis. So today we are going to discuss functions of a complex variable. Functions of a complex variable. We know that the functions of real variables. So for example, the functions of real variables are fx is equal to x square, fx is equal to x, fx is equal to x cube. These are the functions of real variables. Now in this section, we are going to discuss the functions of complex variables. We know that any complex number is generally denoted by z. So, f of z is function of complex variable. Where z belongs to domain of definition of function f. Domain of definition of function f. So in general, the functions of complex variables are denoted by f of z. Also, f of z is equal to w, where w is the image of the function f at point z. F of z is equal to w. So it can also be written as f of z is equal to w is equal to u plus I or u of xy plus I v of xy. So u of xy and v of xy are the functions of real variables. So u is a function from R2 to R and v is a function from R2 to R. So in general, the function of complex variables is denoted by f of z is equal to w, which is equal to u plus iv. So u is the real part of this function and v is the imaginary part of this function. For example, f of z is equal to z. F is a function from set of complex numbers to set of complex numbers, which is defined as f of z is equal to z square. Now I am going to find what is the real part of this function and what is imaginary part of this function. So z square is what? X plus iy whole square. So it is what? X square minus y square plus 2i xy. So f of z is equal to this. So this is the real part of this complex number and this is the imaginary part of this complex number. So u of xy is x square minus y square and u of xy is equal to 2xy. And these two, both u and v are the functions of real variables, and x square minus y square is a function from R2 to R and 2xy is a function from R2 to R. So in general, the given function of complex variables is denoted by w is equal to f of z. W is equal to f of z. And it can be also written as w is equal to f of z is equal to u of xy plus I u of xy. Now, when the polar coordinates are used, We know that every complex number can be written as e raised to I theta. So when the polar coordinates are used, when the polar coordinates are used, then f of z is equal to f of I into e raised to I theta is equal to u of r theta plus I times v of r theta. So when the polar coordinates are given, then the functions of complex variable is f of z is equal to f of r into I raised to e raised to I theta is equal to u of r theta plus I u of r theta. Now, for example, f of z is equal to z square. F of z is equal to z square. Where z is equal to r into e raised to I theta. Then f of z is equal to r into e raised to I theta square is equal to r square into e raised to I 2 theta. So it can be also be written as r square into cos 2 theta plus I sin 2 theta. So multiply by r square, then r square cos 2 theta plus I r square sin 2 theta. Then what is u of r theta? U of r theta, that is the real part of this function, is r square cos 2 theta, and what is the imaginary part of this function? So v of r theta is equal to r square sin theta. So these are the two ways to write the given function of complex variables. Now let us discuss another example. Every real function can be written in terms of functions of complex variables. So f is a function from C to C defined by f of z is equal to mod of z square. We know that z is equal to x plus I. Then mod z is equal to in square root x square plus y square, and mod of z square is equal to x square plus y square. Now this is the real valued function of complex variables. This is a real valued function of complex variables. So f of z is equal to mod of z square is the real valued function of complex variables. So this function can be written as the f of z is equal to mod of z square is equal to x square plus I square plus I times 0. So this is a real valued function, but we can write this function in the functions of complex variable form. So u of xy, that is the real part of this function, is x square plus y square, and v of xy, that is imaginary part of this complex valued function, is 0. So these are the ways to denote the function of complex variables. So we have discussed w is equal to f of z is equal to u of xy plus I v of xy. So these are two real valued function. So u is a function from R2 to R and v is a function from R2 to R. So this is the real part. Real part of w is Re of w is equal to u of xy and imaginary part of w is equal to v of xy. When the complex number is defined in polar form, then if z is equal to r into e raised to I theta, then f of z is equal to f of r into e raised to I theta is equal to u of r theta plus I v of r theta. Now, the real part of f is equal to u of r theta and imaginary part of the function f is equal to v of r theta. So this is about the functions of complex variables. So today's lecture I am going to stop over here. Thank you.